Josh is in the lab today, and he brought with him some awesome ants, Gigantiops destructor. And we've been filming them doing things like jumping off of platforms, jumping onto our finger, and things like that, because Josh actually studies jumping behaviors and other behaviors in ants. But Josh, what would you say your research expertise is in?
Well, I primarily study the mechanics of movements in ants, specifically the mandible strikes of trapjaw ants. But I also work on other projects in different species of ants, like studying the mechanics of jumping in Gigantiops destructor.
Yeah, so we actually filmed all this stuff for a video that will summarize his research results on the mechanics of their jumps. But before we publish that, we wanted to actually put out a video that sort of highlights the natural history and the behaviors of this incredible species. Gigantiops destructor might be the best species name ever. 100 years ago, biologist William Morton Wheeler wrote, "The name conjures up visions of a huge-eyed, insatiable monster, a kind of cyclopean insect jaguar." Gigantiops refers to this ant's giant eyes, but destructor, the specific name, was given to this ant in 1804 by a zoologist who likely never saw it alive. If you came across Gigantiops in and around the Amazon rainforest, this is what you might see: a lone worker wandering through the leaf litter, jumping between gaps in the foliage. The temperament of these ants is about as opposite of destructor as possible. They're so curious and non-aggressive that if you wave your finger in front of them, they jump up onto it and then just walk around and hang out on your hand. They put their jumping ability and huge eyes to use while navigating the chaotic forest floor. Unlike a lot of other ants, they don't follow pheromone trails or cooperate to transport food. Each worker goes out of the nest on its own, and when it comes across a gap in the undergrowth, they size up the distance and make the leap. In a recent study, researchers found that Gigantiops is able to navigate mazes using only visual cues. In the experiment, the ants learned that a wide vertical line meant they should turn left, and a thin vertical line was a right-hand turn. After given a piece of food, the ants were challenged with a maze, marked with these visual cues in a random order. The researchers watched as the ants used the shapes to navigate the maze and choose the right path back to their nest. Beyond visual navigation, jumping is their other incredible talent. Gigantiops is one of only a few ants that uses its legs to jump forward. Other ants that jump with their legs include the Australian jack jumpers of the genus Myrmecia and ants of the genus Harpagnathus. Even some species of trapjaw ants, who are famous for using their spring-loaded jaws to jump backwards, are also known to use their legs to jump forward across gaps in the understory. While other jumping ants have sister species in their same genus, Gigantiops sits alone on its own branch of the evolutionary tree. There are no other Gigantiops species. It's one incredible species living among multitudes in the Amazon rainforest, and it's one small reason to admire, respect, and protect our natural world. So that's a little bit about the biology of these jumping ants. The next video that we'll publish about them will be a summary of your research results. Do you want to give a preview of those?
No, I don't want to give anything away. No spoilers. You'll have to watch the next video to find out.
Okay. Yeah. Well, stay tuned. The next one will be Josh's research results, which are pretty interesting. Thanks for watching this video.
Yeah. Bye.